Welcome to the Karma V2 training course. In this session, we'll be diving into what Karma V2 is and how it can be a powerful tool in the hands of Infosec researchers, penetration testers, and bug hunters. Karma V2 is a passive open-source intelligence, OSINT automated reconnaissance framework designed to assist in uncovering deep information and assets, bypassing WAF CDNs to discover IPs, and exposing both internal and external infrastructure, as well as publicly exposed leaks. This course will equip you with the knowledge and skills needed to effectively utilize Karma V2 for your cybersecurity needs. Karma V2 is a passive open-source intelligence, or OSINT, automated reconnaissance framework. This versatile tool is widely utilized by Infosec researchers, penetration testers, and bug hunters. Karma V2 assists in uncovering deep information, discovering more assets, bypassing WAF CDN to reveal IPs, and exposing internal and external infrastructures. Additionally, it identifies publicly exposed leaks and other crucial findings. Karma V2 offers a powerful and flexible feature set for OSINT reconnaissance. One of its key features is the ability to leverage Shodan Dorks for advanced search results. It also supports SSL SHA-1 checksum and fingerprint searches. Uniquely, Karma V2 ensures that only in-scope IPs are targeted and meticulously verifies each IP against a regex pattern for SSL TLS certificate issuers. The tool can also identify out-of-scope IPs to maintain a clean and focused target list. Additionally, Karma V2 is capable of discovering all ports, including well-known, uncommon, and dynamic ones. In terms of security vulnerabilities, it can gather all target vulnerabilities related to CVEs, which is particularly useful for security professionals focusing on vulnerability assessments. This comprehensive functionality makes Karma V2 an invaluable tool for Infosec researchers, penetration testers, and bug hunters. On this slide, we continue to explore additional features of Karma V2. To enhance data gathering, Karma V2 performs banner grabbing for each IP, which includes details about the connected products, operating systems, services, and organizations. It also has the capability to grab Favicon icons and generate their hashes using the Python 3 MMH3 module. By employing a custom template with nuclei, it can detect technologies based on these Favicon hashes. Furthermore, Karma V2 conducts ASN scans and analyzes BGP neighbors to provide deeper networking insights. Both IPv4 and IPv6 prefixes are used to ensure comprehensive ASN profiling. Lastly, it excels in detecting interesting leaks and services that could be crucial for identifying potential security vulnerabilities. In this slide, we're covering the installation process for Karma V2. We'll go through it step by step to make sure you're set up correctly. First, you need to clone the Karma V2 repository. Open your terminal and run the following command: bash git clone ht/github.com/tirajmadakash karma-v2.git. Next, you'll need to install the Shodan and MMH3 Python modules. This can be done with the pip package manager. Bash python 3-m pip install shodan mmh3. Finally, for this part of the installation, you'll need a JSON parser. The recommended tool is JQ, which you can install using bash ept install jq-yy. Follow these steps and you'll have the initial setup ready for using Karma V2. In this step of the installation for Karma V2, we will be installing several additional tools required for the setup. First, we need to install hteatrobe by tomnomnom. To do this, use the command go install v github.com/tomnomnom/teaprobe at master. Next, we have to install interlace by coding O. This can be done by cloning the repository from GitHub with the command git clone github.com/codingo/interlace.git and then follow the instructions within the repository to complete the installation. After that, we need to install nuclei by project discovery. Use the following command: go install v-github.com project discovery/nuclei v2/nuclei at latest. Lastly, we need to install lolcat, a tool for rainbow coloring your terminal outputs. You can install it using the command apt install lolcat-y. These steps ensure that all the necessary dependencies are installed for the smooth running of Karma V2. Let's continue with the installation process for Karma V2. First, you'll need to install anu by executing the command go install -v github.com/tomnomnom/anu at master. This will allow you to manage and sort unique entries in a streamlined way. Next, create a file named .token and add your Shodan Premium API key to it. You can do this by running the following command and replacing Shodan Premium API here with your actual API key: cat token Shodan Premium API here. This step is crucial as it enables Karma V2 to access Shodan's services using your Premium API key. To start using Karma V2, you'll need to familiarize yourself with its basic commands. One of the first things you might want to do is check the help documentation to understand the tool's capabilities and options. You can do this by running the following command: bash Karma score v2 h. This command will display the help information, providing you with details on how to use Karma v2 effectively, including descriptions of various modes, parameters, and additional options you can leverage for your security assessments. Make sure to review this help output carefully to get a full overview of what Karma v2 can offer and how to implement its features for your specific use cases. In this slide, we'll delve into additional modes and usage examples for Karma v2. IP mode. This mode allows you to analyze a specific IP associated with a domain. You can use it by running the command bash karma v2 d domain.tltld IP. ASN mode. If you're interested in analyzing autonomous system numbers ASNs for a given domain, you can use the ASN mode bash karma v2 d domain-asn. CVE mode. This mode focuses on identifying common vulnerabilities and exposures CVEs related to the domain. To use this mode, execute bash karma v2 d domain.tld-cve. These examples showcase how powerful and versatile Karma v2 can be for performing in-depth domain analysis in various contexts. In this slide, we continue discussing the usage of Karma v2 by exploring more modes and their examples. First, we have the CVE ID mode, which is used to detect specific CVE vulnerabilities by their ID. You can run it with bash karma v2 dom.tld-led cv 2021-34473. Next, the Favicon mode helps identify potential security issues related to website favicons. Bash karma v2 domain.tl integer favicon. Lastly, we have the leaks mode, which searches for information leaks associated with the domain in question. Bash karma v2 d domain.tl leaks. Each of these modes targets different aspects of security assessments, enhancing the tool's versatility and depth in covering vulnerabilities and leaks. Deep mode in Karma v2 is designed to provide comprehensive analysis by supporting all previously discussed modes. When you activate Deep mode, it will execute tasks across CVID, Favicon, and Leaks modes collectively. To run Karma v2 in Deep mode, you can use the following command: bash karma v2 d domain.tld.deep. This mode ensures thorough scanning and data collection for the specified domain, offering a consolidated approach to vulnerability detection and information gathering. In this slide, we will discuss the output of Karma v2 and its directory structure. When Karma v2 is executed, the results are saved in a well-organized directory format. Here is an example directory structure for the output. The base directory is named with the target domain and the date of the scan, for instance, output/bugcrowd.com /mmdd. Within this directory, you will find several files and subdirectories. ASN's detailed bugcrowd.com.txt. This file contains detailed information about the autonomous system numbers ASNs associated with the target domain. Collect, a subdirectory that stores collected data. IP vulns. This subdirectory includes vulnerability data related to specific IPs. Favicon's domain.tltxt contains information about the favicons found on the domain. Host enum domain tltxt. This file includes host enumeration details. IPS in-scope domain.tltxt lists the IPs that are in scope for the scan. Main domain.tld.data, a file containing the main data collected about the domain. This structured format helps in easily navigating and analyzing the collected data. Each component serves a specific purpose, making it straightforward to access and understand the scan's output. Continuing with our course on Karma v2, let's delve into the newly added Shodan Dorks. These dorks are specific search queries that help in identifying specific types of technologies or configurations within Shodan's database. Here are a few examples of newly added Shodan Dorks. SonarQube. This dork helps in identifying instances of SonarQube, which is an open-source platform used for continuous inspection of code quality. Apache Hadoop node. Use this dork to discover nodes in an Apache Hadoop cluster, helping you find big data processing systems. Directory listing. This dork identifies web servers that have directory listing enabled, a common misconfiguration that can expose sensitive data. Oracle Business Intelligence. This query targets Oracle's business intelligence solutions, which might reveal dashboards and analytics tools. Oracle Web Login. This dork can locate Oracle Web Login pages, which are entry points to various Oracle web applications. This search helps in finding Docker installations that might have been exposed to the internet. Apache Status. This useful dork finds servers with Apache status pages enabled, revealing server performance data and sometimes sensitive setup information. These dorks enhance the scanning and data gathering capabilities of Karma v2, offering a more comprehensive view of the target infrastructure. This is crucial for security assessments and vulnerability analysis. Let's take a look at some of the Shodan dorks that Karma v2 supports. These dorks are specialized search queries that can be used to find specific information indexed by Shodan. Here are a few examples. ssl.cert.fingerprint. This dork is used to search for devices or services using a particular SSL certificate fingerprint. http.status302auth. This query helps to locate systems that are using OAuth and returning a 302 HTTP status code. Server Jetty. By using this dork, you can find servers running the Jetty web server. SSL. This more general query searches for services using SSL. http.status302SSO. This dork is used to find systems with single sign-on configurations that return a 302 status code. XAMS bucket region, useful for discovering Amazon S3 buckets and regions. Org. This is a more general search within a specific organization. Title: 401 authorization required. Helps to locate sites or services that require authorization and return a 401 status code. These are just a few examples of the supported Shodan Dorks in Karma v2, and they can be instrumental in gathering specific intelligence during your security research or assessments. In this slide, we're looking at a real-world example scenario where an Infosec researcher leverages Karma v2 to gather extensive intelligence on a target domain. The researcher utilizes various modes in Karma v2 to collect a wide range of data, including IP addresses, autonomous system numbers, ASNs, common vulnerabilities and exposures, CVEs, Favicons, and data leaks. This comprehensive approach allows the researcher to build a robust profile of the target domain's infrastructure and potential security gaps. In our continued examination of the real-world example, let's focus on the outcomes of the researcher's efforts. The findings were quite significant. Multiple vulnerabilities and misconfigurations in the target domain were discovered, which could pose critical risks if left unaddressed. By utilizing Karma v2, the researcher was able to gather detailed information about the target's infrastructure, giving a comprehensive view of potential security gaps. This highlights the tool's effectiveness in uncovering valuable insights that might otherwise go unnoticed. In our real-world example continuation, we now focus on the best practices for leveraging our intelligence gathering tool effectively. First, it's essential to use different modes to ensure comprehensive intelligence gathering. This approach enables you to uncover a broader spectrum of potential issues. Next, regularly updating the tool and its dependencies is crucial to keep up with the latest security threats and vulnerabilities. Finally, thoroughly analyzing the output is key. This in-depth analysis helps identify and address potential security issues, ensuring the target's infrastructure remains secure. By adhering to these best practices, we can improve our security posture and mitigate potential risks more effectively. Question 1 on this slide addresses the purpose of the Nice Deep mode in Karma v2. We have 3 options to consider. A. To perform a shallow scan. B. To support all modes simultaneously. C. To scan a single IP only. As we discussed earlier, it's essential to understand how various modes function to utilize the tool effectively for security analysis. Think about the scope and purpose of the deep mode in this context and select the answer that best aligns with its capabilities. The answer to question 1 is B. To support all modes simultaneously. This feature, known as the deep mode in Karma v2, provides a comprehensive scanning capability. By enabling this mode, you allow Karma v2 to support all other available modes at the same time, ensuring a thorough and versatile scan. This is particularly useful for extensive security assessments where leveraging the strengths of multiple scanning modes can reveal a wider range of vulnerabilities. Question 2. Which tool is required for multi-threading in Karma v2? The options are A. Nuclei, B. HTTP robe, and C. Interlace. When working with Karma v2, multi-threading is essential for efficient task processing. Among the given options, choose the tool specifically designed for multi-threading capabilities within Karma v2. Answer 2. The correct answer is C. Interlace. Interlace is the tool required for multi-threading in Karma v2. It enables the efficient processing of tasks, making it indispensable for handling concurrent operations within the framework. This capability ensures that tasks are executed swiftly and effectively, optimizing the performance of Karma v2. In question 3, we ask about the role of the Shodan API key in Karma v2. The options provided are A. To access the internet, B. To query Shodan for reconnaissance data, C. To encrypt data. It's important to understand that the Shodan API key plays a critical role in the functionality of Karma v2. Specifically, this key is used to query Shodan's extensive database, allowing Karma v2 to gather crucial reconnaissance data. This facilitates a better understanding of the network landscape and potential vulnerabilities, which is integral to the reconnaissance phase of any security assessment or penetration testing process. Answer 3. The correct answer to question 3 is B. to query Shodan for reconnaissance data. Explanation: the Shodan API key is utilized to access Shodan's extensive database. By using this key, Karma v2 can gather reconnaissance data, which is crucial for understanding the landscape of potential targets and security postures. This allows users to perform detailed searches and obtain specific information about devices and systems connected to the internet, enhancing the effectiveness of their reconnaissance efforts. Question 4 on this slide asks, which mode would you use to find vulnerabilities related to CVEs? Our options are A. ASN, B. CVE, C. Leaks. When dealing with vulnerabilities specifically related to common vulnerabilities and exposures, CVEs, the correct mode to use is -CVE. This mode allows us to directly identify and address various security issues documented in the CVE list, which is essential for maintaining a robust security posture. Entering the -CVE mode triggers the tool to search and report on those specific vulnerabilities, providing valuable information for mitigating risks. Let's proceed to the next slide to see the explanation for this answer. Answer 4. The correct answer to the question is B, -CVE. Explanation: in Karma v2, the -CVE mode is specifically designed to identify and report vulnerabilities that are part of the Common Vulnerabilities and Exposures CVE's database. This mode leverages the extensive CVE repository to help security professionals detect and address known security flaws in their systems. Utilizing -CVE ensures that you can stay informed about vulnerabilities that have been publicly disclosed and cataloged, making it an essential tool for keeping your environment secure. Question 5 asks, which command installs the nuclei tool? The options provided are A. apt install nuclei, B. go installed v github.com/project discovery/nuclei v2 nuclei at latest, and C. python 3-mpip install nuclei. To correctly install the nuclei tool, you need to use a command that places it seamlessly within your Go environment. It's important to understand each option to make an informed choice. Option A suggests using apt, a package manager common in Debian-based systems, but it doesn't align with the standard installation method for nuclei. Option C uses pip, a package installer for Python, which again is not relevant for this tool. Therefore, looking at these choices, the correct command is B, go installed v github.com/project discovery/nuclei v2/nuclei at latest. This command leverages go install, a method recommended for Go-based tools, ensuring all dependencies are appropriately handled within the Go environment. The command that installs the nuclei tool, go install v github.com/project discovery/nuclei v2-nuclei at latest. This uses the go install method, which is the correct approach for setting up the nuclei tool. This is the most efficient and recommended way to ensure that you have the latest version directly from the repository. This concludes the Karma v2 training course. If you enjoyed the content, please leave a like to show your appreciation. Don't forget to comment below with any thoughts or feedback you have. Make sure to subscribe to the channel for more detailed courses and tutorials. Lastly, consider sharing this course with your friends and colleagues who might also benefit from it. Thank you once again for participating.